Okay, let's get going again. So this is an example of acceptance testing, which is a very common scenario where we use, we take random samples of things and calculate confidence intervals. So scenario here is 5-star restaurant in a hotel somewhere. Typically those restaurants, every 5-star hotel will have some sort of a restaurant that does breakfast, and so it's very busy in the morning. People come and get their breakfast, and one of the things that is always on the menu is some versions of boiled, fried, steamed eggs and omelets. So they use quite a lot of eggs. So the setup here is that we've got this hotel. Every Monday, the restaurant gets a delivery of 3,600 eggs from a supplier, and the contract with the supplier specifies that it's for each delivery, the median size of the eggs supplied will exceed 59 grams. Now, what you don't want to be doing in that situation is have some poor person in the restaurant weigh 3,600 eggs that are arriving in boxes every Monday morning. So you come up with a system where 30 eggs are randomly selected from the 3,600. Those 30 eggs are accurately weighed for about 1/10 of a gram or so, and then a confidence interval is calculated. And when you look at that, you'll be able to tell, you'll be able to tell straight away whether the contractual requirements being met. So this is this really common thing that happens. Let's just think about it in terms of a decision-making context. In that situation, what's actually happening is every week you're making a decision about whether to accept the delivery of eggs or whether to do something about the delivery of eggs if that specification is not met. Complain to the supplier, threaten to terminate the contract, or whatever. And so you've got some decisions there, some decision alternatives. You've got to weigh up the consequences and preferences and so on. You know, having a fight with a supplier might be a bad idea. If you reject a delivery of eggs, you've got a problem. You've got to find 3,600 eggs from somewhere else in a hurry, and so on. So a key bit of evidence here is about the average weight of the eggs. Is the specification being met? So in this case, the population is really straightforward. The population is this Monday's delivery of eggs, 3,600 eggs. You know exactly what the population is. You know where to find every member of the population. They're all in boxes. They're all sitting there in the delivery dock at the back of the hotel, or they've been brought somewhere into the kitchen or whatever. So for this to work, the really key thing though is you've got to get the sampling right. You've got to get a representative sample, and you remember the random sampling criterion is that every egg has to have an equal probability of being chosen for the sample. So you've got to come up with some system for doing the sampling that will enable the restaurant manager to supervise the process of sampling and weighing and so on. These are weights, they're ratio level measurements. In general, confidence intervals make sense for interval and ratio level measurements. So the eggs are delivered in 100 boxes, each of which contains 36 eggs. And so what you do is you randomly select 30 boxes from the 100, and then you randomly select one egg from each box. And the way you would do that is you'd come up with box numbers. So they would be a randomly selected column of numbers from 1 to 100. And you'd also come up with a set of egg numbers, which will be numbers from 1 to 36. and you'd have some rules about how to identify, say, box number 25, and you'd also have rules for how to identify, you know, the 24th egg in the box, maybe sort of counting along the rows in the box and down the columns or something. It's usually not too hard to come up in this sort of situation to come up with some sort of a rule. A table like that is very straightforward to generate in spreadsheet software like Excel. So you've got a sampling plan there, and then away you go. So some poor person in the restaurant has to weigh 30 eggs on some accurate scales. They get some data, and then you can actually have all this set up in advance in a spreadsheet. It's pretty straightforward to do. So these are the results. The way I actually got these numbers is I went to the supermarket and I bought 60 eggs, and I randomly selected 30 of them and weighed them. So it's actual real egg data. So all we need to know is the interquartile range and the size of the sample, so and the median. So we've got those there. We work out the standard error in the usual way. With this formula, it comes out at 0.287, and we can then calculate the lower bound and the upper bound of the 95% confidence interval. And so we can say at the end of all of this that we're 95% confident that the median weight of the delivery of 3,600 eggs is between 60.9 and 62.0 grams, and that's comfortably bigger than the contractual requirement of 59.0 grams, and on that basis the delivery should be accepted. And again, I checked that with bootstrapping and got pretty much the same answer. There are different techniques you can use to estimate these kind of standard errors, and they tend to all produce fairly similar results. I've always been pretty pleasantly surprised with this little formula for the standard error of the median, because it really seems to work pretty well. So that's good. Now, what I want to talk about is how you really interpret this kind of statement. So this is an explanation of what a confidence interval actually means, okay? So if you took 100 random samples, so we just did one, okay? So that's you just take one random sample and you do your calculation, you get a confidence interval. But what it actually means is this is what you're actually saying when you produce a 95% confidence interval. If you repeated that process 100 times, so you randomly chose 30 eggs, weighed them, calculated a confidence interval, then you put the eggs back, and then you generated another sampling plan, random sampling plan, and you took another sample of 30 eggs, which might include some from the first one, and then you do the calculations again, another 95% confident interval, and you just keep doing that 100 times until you've got 100 confidence intervals. You would expect that 95 of those confidence intervals would include the true median of the 3,600 eggs, the true median weight of the 3,600 eggs. That is the technically correct meaning of a confidence interval. Now, you try explaining that to someone in the real world, and most people just get confused. Most people get confused trying to explain it. So what I suggest is you just try and get away with saying you're 95% confident, okay, and just stick to that. But if a statistician ever asks you, that's what you need to say, okay. What you should not say in the presence of a statistician is that there's a 95% probability that the true population median egg weight is between 60.8 and 62.0, in other words, inside the 95% confidence interval. Now, the true situation actually is this thing that you should never say is very close to being true for this simple case of a point estimate of a median or a mean or something. Okay, 95% confidence intervals. Yet there is another very complicated way you can calculate a different kind of interval it's usually called a HDI interval, where you can say this forbidden thing and it's true. Okay, and what happens in simple cases like this, if you calculate this other complicated thing, this HDI interval, it's usually almost exactly the same as the 95% confidence interval. So although this is not technically true, this is not mathematically true, it's not far off in terms of the real world. So you can sort of secretly think this, just don't go saying it in front of anyone that knows their statistics, because they'll pull you up, probably. Although I've seen, there's been research done that where they go around and they kind of, they survey doctors and things and scientists, and high percentages of them say this. They get it wrong. They don't understand really the true meaning of confidence intervals. So let me just say, I'm not going to test you on this. I'm not going to, but I think it's probably worth trying to remember the true meaning of what a confidence interval is. There are other situations where this forbidden thing is definitely not true. Okay, I think, for example, it's probably not true. You can calculate in linear regression, you can calculate confidence intervals for R squared, for example. I doubt that that's true for R squared. So it's generally better not to just talk that way. Okay. Any questions before I go on to the next little bit? Okay. So this is the next bit I just wanted to add about latent construct measurement. So with physical measurement, we generally use the terms trueness and, we use the terms trueness and precision. In the behavioral sciences, where we're generally often measuring latent constructs like job satisfaction and organizational commitment and so on, we use the term validity instead of trueness, and reliability instead of precision. Now, so validity still basically means the same thing as trueness. It means, is the measurement process we're using, which is very often getting people to complete a questionnaire, is that actually measuring the measurand that we say it's measuring? So if I give you a questionnaire to do to measure your job satisfaction, the validity is about whether the score on that questionnaire, when we add up the numbers in for your answers or whatever, whether that score is actually measuring your job satisfaction and not something else. And the problem that behavioral sciences and social sciences face with this kind of latent construct measurement is proving that that's the case. Because, in the physical measurement world, so just in the case I just gave you about the students measuring that little beer bottle opener, I had a very precise tool that I could use to get an alternative measurement. And there are lots of even more precise tools I could use to get a measurement. There are lots of ways of sort of triangulating whether you're actually measuring the measurand correctly. But with this psychological stuff, with this latent stuff, you tend not to have that. Often the best you can do is you can say whether your questionnaire to measure job satisfaction is the scores are correlating with somebody else's questionnaire to measure job satisfaction. So you might come across this when you're doing your critically appraised topic, as you'll see somebody will be saying, how do we measure something? And they say, okay, well, what we did is we used some questions that we came up with, and we also got the people to answer some questions from somebody else's widely used questionnaire, and the correlation was 0.8. And so we assume that they are both measuring the same thing, and the other guy's questionnaire is widely believed to measure whatever it is, job satisfaction and so on. So this validity thing, the equivalent of trueness in latent construct measurement, is a big deal. And when there are lots of articles, journal articles you'll find, which are about the development of new questionnaires to measure things. And a lot of the stuff in the questionnaire is trying to convince you that the questionnaire is actually measuring the measurand that it's it's meant to be measuring. Yes, Sarah.
Could you like test this thing with like a p-test, like if it's not measuring what's happened before and what's happened now, like to test these latent constructs, like
Um,
potentially?
so you can, the precision part's fine. You can, that's, I won't say it's easy to do, but it's very doable. It's the validity part that's, so what you'll find is they have whole lots of different types of validity they talk about. So one of them, for example, is face validity. And what that means is you get a bunch of experts to look at your questions and say whether they think those questions are likely to be measuring, organizational commitment. So that's one. So you get face validity, and then somebody else will. I can't even remember the names of all these things. There's about over 100 of them. Um, Another one is you're developing an organizational commitment questionnaire, but there's a standard one already that's been used for 40 years that everyone uses, and so you get your subjects, the 200 people or something, you get to answer your questionnaire. You get them to also answer the established one, and then you show that there's a high correlation between the scores, and you conclude, well, that shows that they must be measuring the same thing. And often that's done in a situation where the established one has 50 questions in it, and you've come up with one that has 15 questions, and so you want to say mine's better because it measures the same thing, but it's a lot shorter. Okay, but it's basically, this is one of the biggest challenges in behavioral research and social research and so on, is many of the things you're measuring are these latent variables that are things in people's heads or even things in social organizations, and you can't measure them directly in the way that you can measure the length of something. You you have to go through a whole process of trying to make a case that your questionnaire is actually measuring the thing that you're measuring. And sometimes what people will do is they'll develop a questionnaire which they end up saying, well, this measures some new thing that nobody's measured before. And we call it this. So that happens quite a bit too. So organizational commitment would have been one of those. If you go back to the original questionnaire that was developed, probably the guys that invented it said, we've discovered this new thing that's in people's heads called organizational commitment, and we have a questionnaire that measures it, and if you want to use my questionnaire, you can pay us $50 per person, and that's a bit how it goes. But so sometimes these are totally new things. I mean, job satisfaction's an idea that's pretty informal, but a lot of these things that get measured with these questionnaires are pretty obscure, except to the researchers that are actually using them. But validity is the big problem with latent construct measurement. Reliability, basically, if you're doing it with questionnaires, so long as you can get enough people to complete the questionnaires, essentially there's statistical calculations you can do that will produce a standard error of measurement for you. So the simplest one, and here I'm talking to people who've done, this might be a smaller group of people that have done statistics courses. I know we've got a few people in this class that have done the second statistics course in the psychology degree. You will have learned about a thing called Cronbach's alpha. It's a statistic, and it turns up all the time in academic papers. You can do a pretty simple little calculation with Cronbach's alpha and get the standard error for a questionnaire or an exam, and so on. So it's quite doable. The reliability part is not the big problem with latent construct measurement. It's making a satisfactory case that what they call a measurement instrument, but it's usually a questionnaire, is actually measuring the thing that it says it's claimed to measure, that it has this property of trueness. So that's the challenge. So IQ is an example where there's been a debate about this for a long time. Okay, there's debates about whether there are multiple types of intelligence, whether IQ tests, are partly measuring intelligence and partly measuring socioeconomic status. And that's a debate about the measurement validity of IQ tests. Much less controversial is reliability. So I think the typical IQ test, there is a standard error of about 3 IQ points. Okay, that's kind of easy to work out. You'll see it with standardized testing of school students. So in Australia we have this national testing thing that students do, I think in, what is it, years 3, 6 and 9 or something, called the NAPLAN. So there's a lot of controversy about what that's really measuring. Is it measuring the kinds of things that it claims to be measuring? Are the things it's measuring important, and so on? That's a highly contested area. The reliability, the precision of the NAPLAN test is not an issue at all. The guys that oversee that are real international gurus in the reliability of tests. Okay, they invented some of the main techniques that are used. So there's no question really about the reliability or precision of those tests, but the validity is debatable. Now, the term validity turns up all the time in social and behavioural sciences, and it's not just used about measurement. So I couldn't find it. There used to be a website, there's an academic somewhere in the UK that used to maintain a sort of running list of different types of validity, because he thought it was a bit of a joke that there were so many of them, but and I kind of agree with him. But there are a couple that we will talk about in this course that are not about measurement really. They're about evidence for causation, and this will start to come up from next week. So one is called internal validity, and that's about how strong basically you use the term internal validity to talk about an experiment or a could be an observational study or whatever, but it's essentially about high internal validity means it's strong evidence for the existence of causation. And then there's another one which is external validity, and that's about whether the results of the study, the experiment or whatever, can be applied more widely, can be generalized. Okay, so the example I give there is if somebody did an experiment about work motivation using 19-year-old Californian psychology students as subjects, to what extent would you believe that that tells you something useful about semi-retired factory workers in Pakistan? That might be quite a stretch. It might be okay, but you'd probably have a lot of questions about that. So just this is one of those big terminology headaches I'm just pointing out to you, that when you read academic papers in the behavioural and social sciences, and that includes management, you will see this word validity all the time, and it can be used to mean quite a lot of different things. But in the specific domain of measurement, validity is about what we would otherwise call trueness, measuring the right thing.